energy. Work and energy, we can explain that. What is work? So let me see the feedback. Please, is anybody there who want to study work and energy? Let me start my work topic, work and energy. Here, what is work and what is energy? We will discuss this one. The next, so what is work? We can say that the product of force and the amount of displacement along the line of action of the force. Okay, of that force. What is work? Work is equal to product of force and displacement. So its unit will be Newton meter. That is, we call it joule. Coming to the next, we will discuss about the horsepower in the later on. Okay, when we have to discuss about the power, then we will discuss about this. Now coming to the topic, our topic was work equal to force into displacement. So when you have to calculate that, what is work, we can say that work equal to force into displacement. To calculate the work on an object, what do we need? We need the force. And what is force? Okay, what is the means we have to calculate the average magnitude of the force. Okay, how much the force we are applying. The direction of the force means the direction of force will define that what is the force is in the same direction of the displacement or it is in the opposite direction of the displacement. Now coming to the next, what is displacement? We need the next quantity, that is displacement. And what is displacement? The magnitude of change of the position. Okay, how much the object is going to change. Okay, is position. Now the direction of the change position, from where to where it is going to change. Okay, so we have got the question and we need to calculate this. Now calculate the work. Okay, if you want to calculate the work during the ascent phase of a raft of the bench, okay, means that when the when this our when the ascent phase is there, that when man is pulling down the uh, bench press, he will see that the lifter, okay, the lifter exert an average vertical force, okay, and it is about 1000 Newton against the barbell, while the barbell moved 0.8 meter upward. So it was in this position, okay, and when the barbell is there, okay, the barbell was there. So in this position, here he is lifting upward. Then what is the work done? So here we got that how to calculate it. Are you able to calculate? Then calculate it. I think nobody is there, but let me try now. Here we have to calculate it, that first we have to write down what is given there. Then force is given 1000 Newton, and plus will indicate that which direction it is. Okay. Now here the force is positive due to push upward. When we are pushing upward, and the displacement is also positive because we are pushing in the same direction upward. So the displacement is equal to plus 0.8 meter. Now we need to calculate this. So calculate the work. We have given here the force equal to 10 Newton. The displacement is 0.8 meter. Now we know the formula, or we know the equation, that is work done equal to force into displacement. Force into displacement. Now to calculate this, we have got force, isn't it? And we have got displacement. Using this force and displacement, we can write down work done equal to 1000 Newton into 0.8 meter. Then when we are calculating this, we will get work done equal to 800 Newton meter. And 800 Newton meter, we call it 800 joule, isn't it? Now here 800 joule can be written as 800 J. Next topic is where our force, our work done. Is our work done negative or positive? So first we will discuss about positive work. What is positive work? Positive work is performed when the direction of the force and the direction of the motion of direction of the motion are same. That is, some examples are given. Ascent phase of the bench press. Okay, ascent phase of the bench press when you're pushing when the lifter is lifting over upward and applying the same force in the same direction. Here you can see that. Okay, the work done is positive. Next is throw of a ball. When you are throwing a ball. When we are throwing a ball. Now when we are throwing a ball, we are applying the same force and if we are in the same direction where it is going to display. When we are pushing off anything, okay, if we are pushing off, we are okay, push up, that is upward phase of a jump. When we are jumping, then also we are applying the force and we are going upward, isn't it? Now to calculate, suppose that we have to calculate the negative work. So the question will be same as if we are doing the previous question, that is during the descent phase. Now previously we have used the calculation for the ascent phase, that is here during ascent phase means in this figure you can see that the okay, the lifter is lifting upward. Now here in the descent phase the lifter is going pulling it downward. Okay, so the lifter has exerted an average force of 1000 Newton against the barbell. Well, the barbell moves 0.8 meters, same again, the same question but downward. It is downward. Now, how to calculate this? To calculate the work, we have to first we have to write down given that, then force equal to 1000 Newton, and force is positive due to push, okay, due to pushing upward. Now, displacement is 0.8 meter. 0.8 meter. So, and it is minus, okay. Here you can see that it is minus. Why minus? Because displacement is negative due to the movement downward. Okay, it is moving downward. So the displacement is negative. But force we are applying upward. Given that 1000 Newton, force equal to plus 1000 Newton. So displacement equal to minus 0.8 meter. Look at this. Now we will select the equation, that is work done equal to force into displacement, the same equation, okay. And again we will put this work done equal to plus 1000 Newton into minus 0.8 meter. Here you will see that work done will be again the same, but only the conclusion is minus 800 Newton. Okay, minus 800 Newton and minus 800 Newton meter, sorry, 800 Newton meter. That we call it minus 800 joule, or we can write down minus 800 J. Coming to the next, then we have understood that the force and that what is negative work. Then we can write down the definition. Negative work is performed when the direction of the force and the direction of the motion are opposite. Only simply what we look, the direction of force, okay, direction of the force and the direction of the motion of an object is opposite. If they are opposite, then we have discussed about the descent phase of the bench press. Okay, now when you are catching the ball, then you are applying the force upward and the ball is coming downward. Okay, when someone is landing downward, okay, when he is landing downward, the force is applied there, okay, but he is going to stop now. He is going to, okay, Next is work performed climbing up stairs. Climbing up stairs. Here you will see that work done equal to force in, okay. We know that force is in displacement. Now work equal to subject, that is weight. Now we have to find out the weight because here now the mass we have formed the mass, okay, that is 165 kg. Suppose a man is here and he is of mass 60 kg. Now if the displacement, then we have to find the height of each step. What the step he is taking, we have to find out the each step how much he is taking. Typically 8 inch, and we know that 8 inch equal to 20 centimeter. Okay, if you multiply from 2.54, you will get approximately 20 centimeter. Okay, coming to the next, work per step. Work per step, that is 650 Newton. Okay, means we are multiplying. How we are getting 650 Newton? It was 665 kg, but we have took that the acceleration due to gravity is about 10 Newton. So when we are multiplying 65 kg with 10 numbers, we are getting 0 point and we are getting 650 Newton, and the displacement is 0.2 meter. So actually the work done by per step is 130 Newton meter. So multiplying by the number of steps he is taking or she is taking, we will get the answer. Next, work on a stair stepper. If stair stepper is there, then what the work done? Then here also we will see that work equal to force into displacement. The same formula. Now here force equal to push. Okay, push on a step. How much she or he is pushing? She is pushing about 50 Newton. Okay. Now the displacement we can see that step height. Okay, how much the height of the step is. If suppose that it is 8 inch. So if you are multiplying 8 into 0.054 meter. Now here it is in meter. Now if you are sending in centimeter, then it will be there. Okay, 2.54. So work per step will be, if you are multiplying this 8 into 0 point, you will get 50 Newton into 0.23 meters, and it will be 101.5 Newton meter. Are you getting bored? I think. But similarly, we have to calculate this. Okay. I'm thinking I should stop my class now. Before after the class, I will see that how work is done and what is work. Here you can see that work, how much the work is going to be done. Okay, the power rate of doing of work is known as power, and power unit we know that. Okay, and unit of power is watt. So work done on a cycle or hygrometer. Let's start now again. Hope that you are bored, I think, but continue our class. And the language you are feeling problem, I think. I will cure my language also. Only empower me and try to do the best. Here work equal to force into displacement. Now force, we know that force is the friction of, okay, belt friction on the flywheel. Example, it is example 3 kgf. So displacement is the revolution of a paddle Mach 6 meter. Okay, the work per revolution will be, okay. So here also the same process, we have to do force into displacement, and we will get the per revolution how much the work is done, and then if the work is more, then we will multiply by the number of revolution by the work done by one revolution. Now coming to the next topic, power. What is power? The simple definition is the rate of doing work is known as power. We know that work is equal to force into displacement. Now power equal to work done by time. So here we can write down power equal to force into displacement by time. Okay. Next we can write down here it is written D, you can write S. Okay, no problem. Or we know that distance by time. Okay, distance by time is a velocity. Then we can say that power equal to force into velocity. So here force, so we can write down the unit what it is. It is foot per second or joule per second or watt. Okay. Now even here the question is given here. I think the last class will be about more than that. Okay. Let me continue the only to power. We will study about energy in the next class. So here it is during the ascent phase of a replay, okay, of the bench press, two lifters exert an average velocity, average vertical force of 1000 Newton against a barbell while the barbell moves 0.8 meter upward. Lift 0.5 meter. Okay, now I think I have to stop my class because you are also getting bored and I am also getting bored. Thank you for this. Hope I think give me some motivation so that this is my first video and I will continue to serve you as a best teacher and teach you in the best way. So please like my channel, subscribe my channel, and if you